So in this video, we're actually going to start talking about abiogenesis. But there's some things we got to get out of the way before we do so. First is the idea that evolution and abiogenesis are two separate things. And I already talked about this in earlier videos of this lecture series, so I'm just going to briefly say one more time that when you talk about evolution, you talk about the change in life, or the process by which life changes over time, or species become other species, or species change within the same species, and things like that. And that those processes have been observed over and over again, and there's a lot of evidence to substantiate that. Abiogenesis is more about the origin of life, and it doesn't really make sense to call that evolution, because evolution is a characteristic of life, so it couldn't only occur after life is in place. So abiogenesis is not the same thing as evolution. So you have to separate the two of them, because you see, the thing is, there is a lot of evidence for the theory of evolution, but to say the same about abiogenesis is a little more iffy. So it is possible to understand and accept the theory of evolution without necessarily accepting and understanding the theory of abiogenesis. There's two separate things. If you think that abiogenesis is too fishy for you, that doesn't mean evolution is fishy. That's something that I wanted to talk about. Second, even though there isn't ever any observation that we haven't actually seen abiogenesis taking place the same way we've seen evolution taking place, that doesn't mean that that's not the way that it happened. Remember, we talked about in evolution that if you put the evidence together, you can say a crime occurred even if you were not there to witness the crime. In abiogenesis, even though never truly ever observed, we have observed several of the steps that we think could be necessary for the generation of abiogenesis process. And that these are based on physical and chemical principles that we based on our understanding about the way the universe is and how it works. And so, in other words, this is actually based on real science. It is not just a theory, it is not just an idea, the way it's used in society, it's actually based on a lot of evidence. But I will be willing to say that because we have never actually observed abiogenesis taking place, it is arguably a hypothesis only, and we start working on the process of actually getting there and showing that life actually started that way. But given the other views of the origin of life, this is the only view that can actually be defended by in scientific ways. And that's the key, though. All the other views, even though perhaps equally iffy, this is the only one that actually has evidence collected in scientific field. So that's why in science, this is the one that we talk about. By the way, when you say the word abiogenesis, biogenesis means to start of life, and the idea that life can only begin from other life. Abiogenesis is the theory that talks about the origin of life as coming without other life. And we're talking about the fact that it's possible for life to have started without other life helping it along, or without some mystical force that actually puts life here. By the way, that never actually answers the question of origin, because you have to ask yourself, when does that life form come from? And if you just say it always was there, that doesn't really answer the question of origin, does it? But either way, the abiogenesis theory is very interesting, and there's a lot we have to talk about for you to actually understand that. Another thing that is actually important to mention is that a lot of arguments against abiogenesis is that there never was a conditions on the earth which were conducive for the process that's described in the abiogenesis theory. In other words, that during the early earth, the conditions, according to what the scientists say early earth was like, were not truly conducive for the process that scientists are trying to say were what created life. And we're going to talk more about this when we talk about the actual process. A lot of people argue that the same things which would possibly have generated the life on Earth would also have destroyed the life of the early Earth. In other words, that the Earth was not the ideal condition for the origin of life through the abiogenesis process as it is described in modern science. But I want to say that that doesn't necessarily negate the theory of abiogenesis. It just says that it's not possible on Earth. But that does not mean it's not possible somewhere else in the universe. And that's why a lot of scientists talk about the ideas of panspermia or transpermia. Panspermia being the idea that life on this planet was seeded by another civilization that brought life to this planet. Of course, there is no evidence, no concrete evidence of that. But that is a possible hypothesis that, cannot be tested. That's the only problem. Just like creationism cannot be tested, panspermia can't really be tested until we actually find life elsewhere in the universe and they say, hey, we were the ones that put life on your planet. So it's not something that we can really test, and it does sound very iffy. Then there's also the idea of transpermia, which is life started in another place, but that comets that came from those places brought life to our planet. In other words, that the organic compounds and the early life forms that showed up on Earth but came from other planets. through comets or other types of cosmic transference. By the way, you may think that sounds kind of iffy, but in fact we have seen many evidences of organic compounds forming in space and of comets with organic compounds on them, showing that the organic chemistry, which is the chemistry of life, is possible even without life, and that these chemicals can be formed in other situations outside of the Earth, and then therefore it's possible that the original area where these compounds formed was elsewhere, and then the Earth was seeded with these organic compounds through comets in the early history of the Earth, where comet strikes were very common. So again, even if abiogenesis was not possible on Earth, it doesn't mean that life couldn't have started elsewhere and then come to the Earth. But just like creationism and vitalism and spontaneous generation, those are not things which can be actually explained with science in ways that can actually be measured and improved. So that's why I'm not going to talk much about those things, and I'm going to limit my discussion of those things to that. But remember, that is a valid hypothesis that still has to be explored. But what I'm going to be talking about in this lecture series is the idea of abiogenesis, which is a process based on physical and chemical principles which can be explained with logic and with science and examined in laboratory conditions to explain how life on Earth could possibly have started. Before we go into that again, one more thing. I want to clarify that abiogenesis is different from the idea of spontaneous generation. Spontaneous generation is an idea that precedes modern science. People used to think that life could just show up out of nowhere. For example, that maggots would just grow on a piece of meat. A scientist called Reedy showed that this was not possible. That in fact what was happening is that flies were laying on the meat and laying their eggs, and that therefore the maggots were coming from the flies. That if you cover a jar with the meat inside of them, the flies would not be able to get to the meat, and then therefore they would get no maggots. And if you put just like a netting on top of the jar and the flies could still smell the meat, then they would actually lay their eggs on the netting, proving that it was the maggots were coming from the flies. Now this experiment showed that life had to come from pre-existing life, and it could not just spontaneously generate. And this was the origin of the idea of biogenesis, that life comes from pre-existing life. Another scientist called Spallanzani did a similar experiment, and he looked at the fact that broth used to go bad because of microorganisms growing inside of it. But if you boil the broth, then the microorganisms would die. But if you left the vial that you boiled open, microorganisms would come from the air and infect the broth again, and then the broth would again be teeming with microorganisms and go bad again. But if you left the flask sealed, the organisms that would not go inside and the broth would not actually go bad. Showing something similar to what Reedy has shown with the meat, but then showing that, see, life can come out of thin air. Of course, other scientists says, wait, that means there are microorganisms in the air. It doesn't mean that life is coming out of thin air. There's just microorganisms in the air, and that's where they're actually coming from. It's not coming from the air itself. It's coming from the microorganisms in the air. So, to prove that, another scientist called Louis Pasteur, very famous, the same one that invented the idea of pasteurization, he actually looked at this process and he made a little alteration. He boiled the broth the same way Spallanzani did, but he put this curved piece of glass on top of the vial that had the broth that was actually boiled, and the microorganisms never went inside, proving that was not the air that was making the broth go bad, but it was actually the microorganisms in the air, because you see the curved still allow the air to go in and out of the vial, but not the microorganisms, because the thing is the microorganisms will go inside but be caught up on this area on the bottom here and would never actually go all the way up. They would die or starve before they got all the way up and into the vial, and therefore never actually cause the broth to go bad. And this is actually used even today still as one way to preserve the chemicals inside of a laboratory or industrial applications, because this little circle protects the occurrence of many microorganisms to actually get to the broth, proving again that life had to come from pre-existing life. That's the idea of biogenesis. Now, ironically, a lot of people who are proponents of the creationist idea or the intelligent design theory use these scientists' research, which is almost 200 years old, to talk about the idea that biogenesis is a thing and that life can only come from pre-existing life. But remember, this is misapplying the concept, because this is talking about life today, modern life. It's not talking about the origin of life. It's talking about how life today comes from pre-existing life, but it doesn't mean that life can't come out of simpler compounds and just organize itself. We'll talk more about that later. But anyways, another thing that's important to understand is that there has been a very, 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 very long time for life to have evolved on Earth. Even though the chances of life are very small, there has been such a huge universe with such a long, long time that it's easy to understand why life on the universe is possible. Because abiogenesis is a process that had a long time to occur. And that's why we think that it's possible. Another thing that's commonly used against the theory of abiogenesis is the idea of some things in life being irreducibly complex. That it is impossible to separate certain pieces of living things, and because if you didn't have everything, it wouldn't work out. In other words, how can life have evolved if you need, for example, think about the cell. You need the cell membrane and you need the DNA for the cell to occur. But without the cell membrane, the DNA would not be possible because the DNA would be destroyed without the protection of the cell membrane. But see, the cell membrane arguably only exists because the DNA actually codes for its existence. So how could you have the cell membrane without DNA and with the DNA without the cell membrane? So it becomes this chicken or the egg kind of thing where it's irreducibly complex. If you take any of the parts, then it's impossible for life to actually occur. Now, as we're going to talk about over and over in this lecture series, that is not necessarily true. And over, science has demonstrated that it is possible for those things to exist separately from each other, and that they actually combining together creates a greater advantage, and that's why you see them like that. But there is advantages for them, and there is possibilities for the existence, even if they are separate. And we're going to talk more about that in this lecture series and address this argument of irreducibly complex systems. And the last thing is that remember that when we think about the origin of life, one of the most common arguments against it is the idea that life is too complex to have evolved without, help. But you have to remember that life is complex now, but that the original life forms were much simpler than the life that exists today. So you cannot compare the current modern life in the way that it is today with the original life form or the very simple beginnings of life. And therefore, it is possible for abiogenesis to take place because you're not trying to create the current life that exists. You're trying to create something much more simple than the life that exists today. And as we talked about in the macroevolution lecture series, complexity in life is not something that's actually trying to be attained. It's not a goal. It is just an accidental byproduct of actually making a greater chance of survival. And that the complexity of life increasing occurs at the expense of the energy coming from the environment. So it's not actually against the thermodynamics theory, or in other words, the law of thermodynamics that says that the universe tends to be more disorganized over time. Because remember, even as life becomes more complex and more organized, the universe is losing energy, and therefore the entropy is still observed. So all of these things are important to talk about before we talk about abiogenesis, because I don't want you to get abiogenesis confused with spontaneous generation. When we talk about abiogenesis, we're not talking about the same thing that scientists disproved in the Middle Ages. It's a completely different thing. When you talk about abiogenesis, remember, even if it's not possible on the Earth, it's still possible that it may have occurred somewhere else. Even if it is something very unlikely, you have to remember there was a lot of time and a lot of spaces in the universe for that to take place, so the chances are possible. And it's based on physical and chemical principles, and it does not need to be as complex as it is today. It started much simpler. And the complex systems that you see today are combinations of steps that occur over long periods of time that did have advantage even if they're not together. So systems can be broken down. They are not irreducibly complex, and we're going to talk about all of these concepts later in this lecture series. But remember, all of this is different from evolution. Evolution is how life changes over time. Abiogenesis is how life started.